We will be using the amperes using clockwise of the loop. Here is the problem. Two 24 volts batteries having an internal resistance of 0.2 ohm and 0.4 ohm respectively supply power to a 2 ohm load. How much current is delivered by each battery? The diagram shows the RA equals 0.2 ohm, RL equals 2 ohm, and RB equals 0.4 ohm. Two 24 volts of battery and directions of current. And here are the solutions. First, KCL at junction 0, we have the IA plus IB minus IL is equals to 0. That is the equation 1. Then for the big loop, which is the TSR PONT, counterclockwise rotation of the loop, we have the EA minus RB minus IB plus RA, IA minus EA. So that would come up into 0.2 IA minus 0.4 IB is equals to 0. That is for equation 2. And this is the big loop explanation about the sign. Negative 0.4 IB because the current of IB has the same direction of the loop counterclockwise. IA goes to the left and loop goes to counterclockwise, which has the same direction. In the positive 0.2 IA, it is because the current of the IA has opposite direction of the loop counterclockwise. IA goes to the right and the loop goes counterclockwise, which is opposite. Now let's go ahead with small loop TSONT. We have the RL times IL plus RA times IE minus EA is equals to 0. We have the positive IL plus 0.2 IA minus 24 equals 0. We will come up with an equation 3, which is 2IL plus 0.2 IA equals 24. And this is the explanation of the small loop. It is positive 2IL and positive 0.2 IA. Positive 2IL and 0.2 IA because the current of IL and IB has the opposite direction of the loop counterclockwise. As shown on the picture, loop counterclockwise, then IA current goes to the right and IL. Now let's get the values of amperes of IA, IB, and IL. First, we have to eliminate the IB using equation 1 and 2 to fit for equation 3 and have the equation 4. So, equation 1, IA plus IB minus IL is equals to 0 times 0.4 to eliminate the IB. Now we have the equation 4 of 0.6 IA minus 0.4 IL is equals to 0. And then let's go ahead with finding IA by eliminating IL using equations 3 and 4. Equation 3, we have the 2IL plus 0.2IA is equals to 4. And equation 4, negative 4IL plus 0.6IA is equals to 0, multiplied by 5 to eliminate the IL. So we will now have a final answer of 3.2 IA is equals to 4 from 0.2 IA plus 3 IA. So we will have IA is equals to 24 divided by 3.2. That would be 7.5 amperes. Now let's go ahead and find IL and IB. To find IL, use the equation 4, 0.6 IA minus 0.4 IL is equals to 0. Substitute the value of IA. We will come up with IL is equals to 0.6 times 7.5 divided by 0.4. IL would be 11.25 amperes. While using the equation 1, IA plus IB minus IL, that would be equals to 0. 7.5 plus IB minus 11.5, that would be IB is equals to 3.75 amperes. And this is the values of IA, IB, and IL. On calculator, press mode, then 5, that is EQN, then press 2. On the equation 1, from the IA plus IB minus IL, we have to input the 1, then the 1, press equals, then negative 1. Then for the second is equation 2, we have to input the 0.2. For B is negative 0.4 and the C is 0. As well with equation 3, input the 0.2. For IB, that is 0. IL 2, then press equals 24. The result would be the same. The result would come up with X is equals to 7.5, Y is equals to 11.5, and Z is equals to 3.75.